If we have a high frequency transmission line, we know the voltage on this transmission line at some position at some time will equals to V0 plus this amplitude times, if this is a lossless transmission line, exponential minus J beta Z plus V0 minus exponential J beta Z. If this is the function of t, you will multiply to the exponential J omega t. Okay? To simplify the question, we only consider it is a function of z. If you consider only z, just get rid of the function of exponential J omega t. The same for current equals to I exponential minus J beta Z plus I okay. Because we already know Z0 characteristic impedance is a ratio of V0 plus over I0 plus will also equals to minus okay. So we can change these original equations to V over, okay? For this term, according to this equation, can also change because this is minus V0 minus okay? Okay. So we define this is a ratio between one direction of voltage and current. But we want to define the ratio between for all of the voltage over all of the current. It is ZL is the position at Z equals to 0. This is a position and this is the impedance. They are different. This is the position Z equals to 0. Another position, this is Z equals to minus length. This is the length. I don't use L because I will use L for later. I save this. If the length of this is length, okay? Because we define the direction of your wave to the load is positive. this equation, the meaning of this equation will become this one. And for any point on it, it is minus 0 for any position. Okay? If a wave going to this direction, it is this wave. When your z equals to 0, it is the position at the load. Do you understand? I know it is weird, but this is because we define when z equals to 0, you don't have other transmission line. And then your wave is going to your load. So this is z equals to minus length, your position. The length is your physical length of the transmission line. So this, the total impedance at here is Z in. This is the Z. Okay, now let's try to explain this first. For another color, for this is ZL, for this is Z in. Okay? Z in will become the total voltage when Z equals to 0. Total I when Z equals to 0 as well. So your Z in equals to, according to this equation, V0 plus V0 minus over okay? Can you see the equation? Because we define here is your position Z equals to 0. You put Z equals to 0 to these two equations. ZL is the Z in if Z equals to 0. Okay? For the any position with the transmission line length equals to Z, it is Z in will equals to every position of your total voltage over your total current. For VZ is exactly this equation. For your IZ is exactly this equation. Okay? But this is a special case for Z equals to 0. For Z equals to 0, you just directly put, because exponential to the power 0 equals to 1, right? So you can simplify your ZL equals to this equation. Okay? So there are two equations we use the structures we can derive. The first is what is ZL? That is this one. Okay? The second is what is the new impedance at somewhere. the position Z, you use the four equation of voltage and the four equation of current. Just put everything here. Okay? Okay. So the first confusing part is why Z is minus here, because this is according to our definition. So Z is minus, 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 minus. Okay? Okay. So back to our PowerPoint. If you understand why we are doing that,
so totally the same picture, the same as what I draw down there. This is a total equation for the total voltage and the total current. You change the current according to the characteristic impedance. You can change the amplitude to this term and this term. Okay? The total impedance at load is the total voltage here over the total current here. That is ZL. The same equation is the green one. I do some organization and I times Z0 to the numerator and numerators, denominators. I can obtain this result. Okay? So then I define something else, the same as what you did for your wave. What is the red color? If your reflection coefficient gamma defined as your reflected wave over your incident wave, this is your reflection coefficient. If you define that, you can then change to I just reorganize. That's for next step. If this one equals to V minus over VO positive, you reorganize this term. Okay, you can use the same equation. You can obtain this one, the reflection coefficient equals to Z0, ZL minus Z0 over ZL plus Z0. This is the same result when we treat remember, right? You have gamma will equals to eta. This is eta eta 2, and this is eta 1, right? Eta 2 minus eta 1 over eta 2 plus eta 1. Remember this equation, right? So you got very similar result from the equation we derived here. Okay. Okay. Yeah, we use this very often. We use this very often. So if you know there is a transmission line, the transmission line has the characteristic impedance 15 ohm. connect this transmission line to a load 100 ohm, then you will know the reflection coefficient will equals to 100 minus 15, 100 plus 15. Okay? But when you read the result from the VNA, the difference is you get the dB unit. So the result will be 20 log this one of this number. You will get some. This is what you measured from your VNA. If there is a 15 ohm transmission line, connect to some impedance, the load impedance. This is how we get the equation. Okay? Then you have the ratio of this one, then we can do more. For these two equations, you can change V0. Can anyone want extra point? Give you 3 points. Change these two equations with, okay, no, because I already write it down. There's no meaning, you just copy, right? Because you don't have the V0 minus, you have a reflection coefficient. You can just use the reflection coefficient instead of yes, right? Just change it, and for the equation, you just take the same part outside the equation. You get these two equations. So, and this is the time average power flow. You can just refer to your textbook. You just put your voltage, the total voltage, and the total current. And because we will take a conjugate to the average power and put everything inside, you can see that you can separate your power to one incident wave and one reflective wave according to, just put every equation here. Okay? You can check the time average power flow from your textbook. And this is written notes, as I said, and you will take. Okay, I think I already mentioned this a couple days ago in our meeting. If you say the reflection coefficient, this is gamma, okay? Gamma can be complex because this one, gamma can be the total term, this term over this term can be complex. But if you want to see only the value, if you take the absolute value of that, you can use only this term. Remember, we calculate this one at z equals 0, so you don't have the phasor problem, right? But our definition of the reflection coefficient, the overall definition, the broad definition of the reflection coefficient is the whole part of the reverse voltage over the whole part of the forward voltage. Okay, so gamma can be complex. But if I want to know the absolute value of that, you just only need to take the magnitude. It's okay. Okay? The reflection coefficient, the definition of reflection coefficient is a complex number with definition, this one. Okay? When you use your VNA to measure your S11 in dB, you will get the result is 20 log of your reflection coefficient. This is S11 in dB. The result of these two unknowns, they are both negative. Okay? The definition of return loss, because we already know it is a loss, so we put a negative sign here to cancel the negative term. So if you say return loss, the number is supposed to be a positive number. This is a very straightforward definition. If you want to say reflection coefficient, or you want to say return loss, they usually have the sign different. This is positive. This is a positive one, because you put a minus sign here to a negative term. So positive, negative will become positive. Because we already know it is a loss. You understand? But if you're talking about the reflection coefficient, it is a negative. Okay? Understand? Reflection coefficient in dB is negative because it's less than 1, so it will be negative. OK？ 好像中文讲这，关一下，有听懂吗？